The first video of the Sting frame was about the ideation and the design process, and after that I had the parts CNC cut and 3D printed, and now I have everything at hand and it is time to build the drone based on that frame design. Super excited to do that together with you, and I'd say let's get started. My name is Nick and this is how I fly. Alright, so here we are, this is it. This is one CNC cut Sting frame. I already connected the side plates using the M2 and 20mm long spacer bolts and M2 6mm or 4mm screws. And the 3D printed part for mounting the antenna is also already connected. It's just connected using a bolt here in the middle and then the outside another screw. Here I used nylon screws. And now how to connect these side plates with the main center plate. What you do is that for the side plates you take another M2 nut, you push it in these openings here. So now the screw is in there, it's perfectly tight, and then you put the side plates onto the main plate. They just connect also very nicely, and then you got this here, and then you need one M2 6mm screw that goes through here, and then you tighten that down, and this creates a super strong connection. And you have 4 of these, so this is really super tight. You can decide to use nylon screws and nuts here. This way you have I don't know the English word for that, but you have a place that if you have a crash and there is force coming from the front here, it is better that if there are nylon screws here, that these snap off, and then this gets, I don't know, it depends on how strong your impact is, but this gets opened a little. I don't think that 4 nylon screws are going to break, but maybe the 2 in the front, and then it has some, force airbag here. So I think I'm going to be using nylon here. But alright, so this is the frame that we are going to use to build everything together today. But what are we missing? Let's see. That's the electronics. And what are we going to use? Alright, so what do we have here? These are all the parts that are going to be put into this frame. And first of all, we have the motors here. These are Flywu Robo RB1202.5 with 11,500 kV. Why am I using these? If you have watched my previous video about the tool called eCalc, it's the one that I use for calculating my builds, and these were the results. As you can see, we do get some pretty nice values that with a very good weight thrust ratio and also other numbers. If you are interested why I chose these, then feel free to watch my video about eCalc, because I explained the process, how I found the motors and all of that, and I think this will be helpful. Alright, but that's for the motors. For the flight control, I'm going to use the Hemsu all-in-one board. This is a flight control board and an ESC 4-in-1 all-in-one with a 20x20 mount option and lots of UARTs that are free and nice big soldering pads, and I really like this board. I will put a link in the description to Banggood so you can check it out. So this is what we're going to use here. Then for video, we are going to use the Caddx Vista, one where I had the case or the heatsink removed, so it is super light. And this is the DJI camera. What I did is I designed an alternative to the standard heatsink that comes with it, that is made out of metal. This one is 3D printed out of PLA, and it saves you another, I think, 1 to 1.5 grams or so. It's not much, but for these small builds, every gram counts. I also put the design on Thingiverse, and I'll link it in the description so you can check it out for yourself. And then there is one part in here that you might ask, what is this? And this is a let me show it to you without heat shrink around it. This is a Real Ag, I think was the manufacturer's name, although it's sold from a few different brands as well. A video switch. And why do I think that a video switch is a good idea? Well, if you use the Caddx Vista in a light naked way, the thing is that when you fly, there is no problem with overheating or anything. And also I always keep the heat protection on, so it will switch off before it will cause any trouble. But let's say I crash this a bit far away, or I crash this in a tree and it takes me some time to get it back out of it. So I'm a bit concerned that it will overheat, and maybe the overheat protection is not going to work out that well. I don't know. I'm just a bit, maybe it's a bit paranoid, but I want to feel extra safe. And this is why I installed this Real Ag video switch, which will allow me to switch off the Caddx Vista with just a switch of the remote, or button, and then I can just, if I don't want to use it, I can just switch it off. This is also helpful when you're flying with others, and you are concerned that when you connect your battery, then that their image transmission gets conflicted. Then you can just use this and then turn it on with a switch when you know they're ready for it. I guess everyone knows that this, when you fly with others, always like, okay, I'm gonna plug it in now, and then no, wait, I'm not, blah blah blah. All of this is not gonna happen if you have this switch. So this is what I'm gonna be using. It's the same one that you can see here, just with heat shrink around it. Okay, then for the antenna, I am going to use the iFlight Sigma left-hand polarized antenna. It just weighs 1 gram. It's lighter than the normal antenna that comes with the Caddx Vista. Even if you like, this is the one that came with the Caddx Vista, but I had removed this stiff plastic here, but still, this one here is lighter, and I prefer using this one. Regarding range, I did not see any difference so far, and I like the smaller form factor. It better fits such a small frame. Then we have, the XT30 connector here. We have a we have a condensator here that will reduce the noise. It is a little oversized. It's 16 volts, 470 UF, but I don't have anything smaller right now, so I'm going to use this and just solder it into here with a power line. On bigger boards, 5-inch boards, you usually solder this right on the flight control, but with this small size, this is not the best option. What I'm going to do is I'll just solder it in here, and then it is also a flexible connection, and I can easily connect the cable. Yeah, and then we have the Crossfire, TBS Crossfire Nano receiver with a Immortal T Mini antenna. I know the performance of this antenna is not really super, but the form factor is good, and it is performing okay. I did not ever have any issues. I mean, Crossfire is a super stable connection anyway, and with these small drones, you're not going to be flying like super extreme far away. Long range is not what you're going to be doing. All right, and then this is the propeller. It is an HQprop T65mm, and they have been performing very well with these light builds. They are easily available, and I had good results with these. I might test this with others, but these are the ones I'm going to be using initially. All right, so these are the parts. Let's put them together. I will try to walk you through the most important steps, like how to connect the Caddx Vista with these boards and maybe the other electronics after I've soldered them up. I will not going to be doing like a super detailed build video where I'm going to be showing you like every little solder joint, but let's just still do this together, so I might be able to answer a few questions that you might have when building your own. All right, so let's start. So, one thing for mounting the Caddx Vista here on the back, what I usually do is that I take a really small rubber that goes beneath the Caddx Vista, so it's not directly in contact with the carbon. And then I take like a nylon screw that goes through here, and now the lower plate of the right orientation, yes, the lower plate of the Caddx Vista goes in here, and then comes, oh sorry, so if you can see, the lower plate of the Caddx Vista goes in here, and then comes a rubber band like the ones that you get with a flight control board, and this goes on top of it, and then comes the upper plate of the Caddx Vista, and this way all the electronics are separated from each other, the two plates of the Caddx Vista, and so you are sure nothing is going to get shortened out. And that we will do for the other sides as well now. Alright, now all four screws are inside. It is a little bit uneven. Let me unscrew this one here a little. Alright, always make sure that the two boards are not directly touching each other. I actually don't think that at this position it does really matter that much, but I still feel better if they are not. So, you know, we can, now if we want to be super clean, we can snip off the upper part of the screws here so they match the ones on the other side as well. That's the good thing about nylon screws, you can just cut them to your preferred length. That's why I like them so much. And also they are light. So, okay, the Caddx Vista is now installed. Now we need to solder everything to the board, which is what we're going to do now. So what I did is, from the Caddx Vista, I connected the TX pad to the RX pad from the flight control. I'm using the TX and RX3, which is a free UART that I'm using. The board has many. You can choose as you like. I used the third one for the Caddx Vista. And I also connected the ground wire with the ground connector on the flight control here from the Caddx Vista to the flight control. And as I'm using the power switch, I connected the power, which is the 9-volt connector here, and also the ground, to the power switch and then to the Caddx Vista. And to connect or to control the power switch, I used the LED pad that I will configure in Betaflight to be a switch on my receiver. And that's how you connect the Caddx Vista to the whole thing. Next up is the Crossfire Nano. Alright, so the Crossfire Nano is now connected. I connected on the outer side, this is the TX connector from the Crossfire. I connected this to the RX from the board, and RX from the Crossfire to the TX of the board, and then I connected 5 volts and ground totally the opposite, which is not the way you should do it. Damn it! Alright, I agree this is not the best soldering, but now I have connected the Crossfire Nano. The outer one is the TX to the RX of the board, the RX from the Crossfire to the TX of the board, and the 5 volts and the ground. And now what I plan on doing is just, put this upside down, maybe like this, and then have the antenna go below here. So next thing is mount the motors and connect them to the board here, which is what I'm going to be doing now. Alright, the 4 motors are in place, and this is starting to look like one really screwed up quadcopter, but if you ever build one yourself, you know that this is what it's supposed to look like. It's soon going to be different. Now we have soldered the motors, we have motor 3, motor 4, and the same on the other side. It's not necessarily my nicest soldering, but it's gonna work, I'm sure. I hope. We'll see. And that is fine. What we now need to do is solder the motor cables, which is not the motor cables, but the power cables for the LiPo. And actually this is something I suggest doing before starting to work on the Caddx Vista cables, because these are now in the way, and this sucks. And now I have to do some annoying soldering work that could be much nicer if I would not have done that before, but whatever. And we soldered and connected the motors, and the connections look pretty okay to me. So now what is remaining is putting the top plate on it, screwing in the camera here, and I think then this is it. Let's do this. Alright, this is it. We soldered everything, as far as I think. What we need to do now is go to Betaflight and configure everything. But what another point of the mounting is how to mount the battery. And what I'm using is this foam, like with a glue tape on one side. I don't know, you can use, there are different usages of this. I guess people have that at home. If not, this is super cheap to get literally anywhere. And then you just glue this in on each side, like on the right side, and let's do it on the left side as well. All right, so this is in there now, and now you can just take your battery, whatever battery that you want to use, and you can just slide it in here. And this creates a really strong, connection. This is not going to get out easily, even in case of a crash, a small crash. I don't think this is going to fly out. And then you just connect the battery here, and then the propellers are free. Nothing's going to get into the propellers. I can, or you can, with a zip tie, also mount this here to the side, which is probably what I'm going to be doing. So it is nice and always in the place that I want it to be, somewhere like this probably. Yeah, but this is it. This is what it's going to be looking like later on. It sits here on these standoffs, so it's not going to be pushing onto the electronics. You can cut this out a bit nicer if you like, but I think this is going to do just fine. Let's do a quick weight check, where we're going to be ending up with. So the frame itself without the propellers. We need to add the propellers. Let's just put them here for now. So we are at 72 grams. Let's zoom out a little so you can see better. So 72 grams without the battery. Now let's put in the 450 milliamps battery. This is one from T2. Like I said, 2-cell. Now we are at 100.2, so we are 0.2 grams above what I was going for, but I think I can live with that. Now, theoretically, what is still missing is a beeper, because, with a quad this size, it's helpful to have a beeper. You can use the ESCs to beep, or you can use one of these, they come from so many names and sizes. This is from, I think, VE Fly, however you pronounce it. There is also one that is even a little bit smaller and lighter. Where can you mount it? Well, you can maybe put it in the back here. It's not super nice, but it's going to work. So that adds another 3 grams around. I always like using, me personally, one of these things. This is, it's called locator, and the O is an 8. And this has been used to find lost keys or your dog. And this does not need to be connected to anything here, because you have a little control unit, and you press a button and then it starts beeping, and it also shows you in which direction you need to go. And I can just squeeze this in here in the back and lock it with a cable or whatever. I don't know. This is probably what I'm going to be using, or I'm going to be putting it here on the front somewhere. I don't know. We will see. Or you just use the ESC beeper. You can also do that. I think this one here goes in nicely So that would also be a good way. Like, then I would need to solder this to the flight control. I need to check which one I'm going to be using, but basically this is it. So we are at 100.3 grams. What you can also do is use a 650 milliamps battery, which I'm also looking forward to trying out. This is one from G&B, the HB series. You need a charger that can charge them up to 4.35 volts, but then you're going to get additional flight time. So this will be interesting to see. And with that, I'm ending up at 100.2 grams. One propeller more, so 103 grams. And then, yeah, depending on which one you use, the beeper, it's going to be around 107 grams. So it's still super lightweight. And yeah, I can't wait to test out the flight characteristics. But yeah, like, this is the frame now put together. Alright, this was the build video of the Sting frame. I hope this was helpful, especially when you are thinking about building your own, which I would really love to see. Please share with me if you do so. And this was the first build video that I did on this channel, and I really hope that it was helpful, because like when I was making it, I already realized how many things I want to make different and better next time, but still, so any feedback from your side would be much appreciated. And yeah, now I guess it's time for me to go out and fly this thing and then find out how I like it, how much I like it, and maybe what I want to change or not. If you're interested in seeing that, then please subscribe to the channel and click the thumbs up, also for all the other project update videos that I'm working on. And yeah, I'm off for today. Thank you very much. Talk to you soon. Bye-bye.